Sorry about that, guys. We had a minor emergency with Jordan. So anyways, if it's not one of these 7, they are not diatomic. So if you'll notice these 7, you'll put a 2 at the bottom. If it's not one of those 7, like lithium, it's not on this list, so it's just single, okay? All right, then we have dinitrogen tetraoxide. This, you see these prefixes, okay? This is nitrogen is a nonmetal. Oxide is a nonmetal. Oxygen is a nonmetal. So this is a covalent molecule, okay? Many of you were trying to do the -3, -2, and cross them over, and you were so confused. This is covalent. Treat it as covalent. It's just nitrogen, 2 of them. Oxygen, 4 of them. That's it. Okay? Moving on. Potassium, magnesium nitrite. So potassium is not on our list, okay? So we just bring it down. Magnesium nitrite, so magnesium metal. This one's a non-metal. So I like to do them up here. Magnesium is a +2 charge. So Mg +2. Nitrite, that's not on the periodic table. If it was nitride, it would be, but it's nitrite. So you find it here. Nitrite, okay. NO2 -1. So we have NO2 -1. Cross them down, okay? So we have Mg1, but we don't write the 1. NO2, parentheses, 2, okay? Arrow, we have magnesium. That's an element. It's just one thing, element. But it's not on the diatomic list, so we're just bringing down the element symbol. Potassium nitrite, potassium metal. This one's non-metal. How do I know if it's metal or not? I told you guys this on the last review, but whatever. If it's from metalloids all the way to the left, these are all metals. All of these are metals. These little bits right here, non-metals, okay? So we have potassium nitrite. Potassium is here. Okay, whoops. K is a +1 charge. Nitrite, we have already established that it's NO2 -1, so these are actually 1-to-1 ratio, so you don't write it. NO2. Okay, done. This next part is balance the following formula equations. So this is kind of the frustrating part. You can do your tally method here if you want. You can just do the trial and error, which is my favorite part. Whatever you're more comfortable with, you should do. So we have zinc here. We have 3 zincs, 1 zinc. So I'm going to put 3, okay? We have 2, sorry. We have 2 phosphates here. We have 1 here. So we need to add 2. Okay, so let's check. 3 zincs, 3 zincs, 2 phosphates, 2 phosphates, 1 aluminum, 2 aluminum, so we need to add a 2. So 2 aluminums, 2 aluminums, okay. Chlorines, we have 6 chlorines, 6 chlorines, so I'm good. I'm happy. Okay, so that's how I like to do it. You can do the tally method where you write down the zincs, the phosphate, and your aluminum, and your chloride, and whatever. You can do that and then put them here. I don't like it, it's weird, but some kids really like it and they want to keep doing it, and that's totally fine. Sorry about the slamming door. There's like a lot of wind outside, and I had to sneak in through the window because I left my keys at home. Anyways, let's move on. We have 1 1 chromium here, 2 here, so I need to add a 2. 3 hydroxides. Actually, we have 3 times 2, which is 6 hydroxides. Okay, so we have hydroxide here, but we don't have it here. So we need to separate it into oxygens and hydrogens, okay? So we have 3 oxygens times 2. So we have 6 oxygens, and we have 3 here and 1 here. So we will have to do this. We can't just like add, I mean, we can add 1 at a time to make it 6, but we don't add too many here. So how I like to do it is do it in a ratio. So, and look at something else. How many hydrogens do we have here? So maybe skip oxygen. How many hydrogens do you have here? And I have 6 hydrogens. So let's skip the oxygens for now and just see if it'll work. Most of the time it does work. So we have 2 here, so we need 6, so we'll write a 3 here. So let's just see what happened. Sometimes I find it easier instead of trying to fix these oxygens to move on. So 2 chromiums, 2 chromiums. Let's do hydrogens. We have 6 hydrogens, 6 hydrogens. Let's look at oxygen. We have 3 times 2, so 6 oxygens on this side. We have 3 plus 3, so that's 6. So we're actually balanced. Most of the time, skip that oxygen and move on. Okay, so now we have sodium, 1 sodium here, and 3 here. So we're going to add a 3 here. So 3 sodiums, 3 sodiums. Is hydroxide on the, no hydroxide. So we're actually going to look at these all individual, okay? You don't have hydroxide over here. Hydroxide, remember, is this. We don't have that, okay? So we're going to do oxygens and hydrogens separate. So we have 1 oxygen here. We have 1 oxygen here and 4 here. So that's 5 on this side. We have 4, 5 on this side. Let's look at our hydrogens. We have 1 hydrogen here times 3. So we have 3. Then we have 6 here. And we have 2 here. So we need to add a 3 here. So let's look at everything and see if it balances. We have 3 sodiums, 3 sodiums, 3 oxygens plus 4, so 4, 5, 6, 7 oxygens on this side. We have 4, 5, 6, 7 oxygens on this side. We have 3 hydrogens plus 3, so we have 6 hydrogens, and we have 2 times 3, that's 6 hydrogens, so we're actually balanced. So, sorry guys, I'm kind of doing this. I haven't done the review, so if I look like I'm not confused, but sometimes I have to think and talk at the same time, and that's a little weird for me. All right, so we're done with the first page. We have one more balancing, and then we're moving on to a different type of problem. So we have lithium, water, lithium hydroxide, and hydrogen gas. So we have lithium, 1 lithium on this side, 1 on this side. That's great, but I'm sure it's not that easy. 2 hydrogens here, 1 here, 3 hydrogens here. So I should have known there was a trick. But anyways, we have 2, 2, 1. So let's change this to 2. We want to get this. You never want to have the hydrogens as like an odd number. You want it an even number. So we have 2 here, 2 here. So then we would just add a 2 here. Because otherwise, if you add I don't know, if you're trying to fix this or this, you don't want it 3 on this side because you know that this will never be an odd number, if that makes sense. Anyways, so we have 4 hydrogens here, 2, 4 hydrogens here, 2 oxygens, 2 oxygens, 2 lithium, so boom, we're done. Okay? All right, next question says to change the word equations into formula and balance them. Okay, this is basically our quiz, right? This was our quiz, and this is what we did. So this is bringing the formula down and then balancing. So we have copper 1 iodate. Okay, so this is metal, non-metal. This is a metal. This is non-metal. This is metal, non-metal, metal, non-metal. These are all covalent bonds. And for fun, let's look at this. This is a compound, so it's going to be a double replacement. But we don't have to deal with that yet. Anyway, so we have Cu, which is a +1 charge. I know that because of the Roman numeral. Iodate. Iodate is on our thing right here. IO3 with a -1 charge. IO3 with a -1 charge. They cross down, but they're 1-to-1 ratio. So it is Cu. You don't have to put parentheses, IO3. Plus. We have potassium +1 charge. I just know that. If you don't just know that, it's right here, group 1 +1 charge. Carbonate. Carbonate is right here with CO3 with a -2 charge. So CO3 with a -1 charge. 1-to-1 ratio again. So KCO3. Okay. Then we have potassium iodate. All of these are -1 or +1 charges, so I'm not going to waste too much time going up here. I will just know that that's KiO3 plus CO3. Okay? So, easy. Now we balance it. So I have one copper, one copper. I doubt it's going to be that easy. So one copper, one copper. Oh, carbonate is not a -1 charge. Anyways, I'm sorry, I read it, I looked at it wrong. Carbonate has a -2 charge. I even said it. Anyways, so carbon here. Carbonate is a -2 charge, copper's a +1, so it's copper 2. This will be K2. My bad. Sorry. Anyways, moving on. We have copper, copper 2, so we have a 2 here. Okay. Iodate, we have 1 here, so that's not good. We have actually 2 here. So we need a 2 here. We have 2 potassiums, 1 carbonate, 1 carbonate. Okay, now we're good. My bad. It's Sunday and I'm like very tired and we're going on a trip tomorrow, so my brain's not all the way here, but I want to do this before I leave so you guys can have time to study. Iron. That's what I get for moving ahead. Iron with a +3 charge. So Fe +3. Carbonate. Let's see if I can get this right this time. Carbonate. CO3 -2. Let me see if I can. -2. There we go. Not screw this up this time. So Fe. Okay. So we have iron with a 2. Carbonate. CO3 with a 3. Plus cesium. So cesium is all alone, so it's elemental. It's not on our diatomic list, so we're just bringing down its symbol right here. So we're just bringing down its symbol CS. That's it. Then we have cesium carbonate. So cesium, if you could tell, was in group 1. So it's going to have a +1 charge. So cesium +1. Carbonate, I will probably never forget it now, is a -2 charge. We're going to bring it down. So we have CS2, CO3, and it's just a 1, so we don't write it. And we have iron. Iron is elemental, so we just bring it down. It's not on the diatomic list, so we don't have to worry about charges or anything. It's just that, okay? Now we have to balance it. We have 2 irons here, 2 irons here, 3 carbonates here. We only have 1 here, so we kind of need to do this. We need to add a 3 here. So then we have 6 cesiums, so we need 6 cesiums here. So let's check one more time. Irons 2, 2, carbonates 3, 3, cesiums 6, 6. Okay, I'm happy with that. Moving on. Sodium chlorate, metal, nonmetal. Sodium chloride, metal, nonmetal. And oxygen. So guys, if you don't like immediate say, oh, metal, not chlorate. Okay, that's a decomposition. It's one of those 3 exceptions. Remember those 3 exceptions: chlorate, carbonate, and hydroxide. Then you should maybe review that. So we have sodium, which is Na +1 right here. Please, guys, don't put sulfur as sodium. That I see so many of you do that, and I just like cringe as I grade it. Chlorate, if it was chloride, we'd be looking at this guy, but it's not, right? It's chlorate. So we are looking at wherever he is, right here, this guy, ClO3 -1, okay? So Cl, that's a big O, 3 -1. All right, 1-to-1 ratio, we don't have to write the 1, so it's just NaClO3. Sometimes I like to put them in parentheses only to make sure that it's not here on the other side. But knowing that this is decomposition, I'm pretty sure it's not on the other side. Now we have sodium +1, chloride, that's the ide, so we know we're talking about chlorine, so it's a -1 charge. So we know that's NaCl, 1-to-1 ratio. Oxygen, that's monatomic. It's part of the... Oxygen is an element, and it's on the diatomic list, so we're going to put a 2 afterwards. Now we need to balance it. We have Na, we have 1 of each. Okay, so since we don't have chlorate on the right side and we do on the left, we have to look at it as a separate element. We can't just say, okay, 1 chlorate here, how many chlorates do we have over here? We can't do that. We have to look at chlorine, and then we have to look at oxygen. So we have 1 chlorine over here, 1 chlorine over here. That's great. We have 3 oxygens over here and 2 over here. Oh. Okay, so just when you see something like this, when you see like something that's not like 4 here, 2 here, oh, all I have to do is add a 2. Just use their subscripts and put it as the coefficient. Then that's your lowest coefficient that you'll have. So you'll have 3 here, 2 here, if that makes sense. Because you can't you can't just add 1 on this side to make it 3, okay? And you can't take 1 away to make it 2. So the best thing to do is to put whatever its subscript is on the coefficient and whatever this subscript is as its coefficient. And we'll probably have to change something else, but that's okay. So we have 2 sodiums, 1 sodium. We need to change that to 2. 2 sodiums, 2 sodiums, 2 chlorines here, 2 chlorines here. We have 6 oxygens, 6 oxygens, so I'm good with that. Okay, so that's it. It's super easy. Predict the products for the following reactions in words only. So now we're looking at those 5 types of reactions. So 5 types of reactions, and we're going to predict what becomes of it, okay? So we have magnesium carbonate. So this looks like, where's my paper I wrote? So we have just a compound, okay? So just one compound, that'd be decomposition. Sorry, you can't see. Decomposition, it's going to just decompose. Unless it has carbonate, chlorate, and hydroxide, which, oh, it sure does. So in your notes and in the PowerPoints, it tells you how these break down every single time. So how this will break down every single time is the metal oxide for carbonate, metal oxide, and then carbon dioxide. So basically a carbonate would break down, and you guys had homework over it. You had like 7 or 8 problems. It should be maybe not like natural, but if you want to write it on your note card, you guys do get a note card, then write the rule on your note card. It doesn't matter. So then we will have magnesium oxide plus carbon dioxide. Now, if you guys remember in your notes, it was like whatever metal carbonate you have, it's going to be that metal oxide plus carbon dioxide. So like this is the part of the product always when you have carbonate here as a decomposition, okay? So this was decomposition, if you want to study that, okay? Zinc perchlorate plus silver. So zinc perchlorate plus silver. This is a compound, and this is a an element. This is a metal. So what we are looking at, if you'll see on our reaction list, is the element plus a compound, and we're going to look at the activity series sheet to see if it'll replace that other metal. So this is 1 metal, this is 2 metals. Let's see who gets to keep the perchlorate. That's where we look at this. So we have... So what we need to see, if this reaction is going to switch places, zinc needs to be below silver. So let's find it. We have zinc here, and silver is at the very bottom. So silver is here. So there's not actually going to be a reaction because silver is below it. So it won't be, I mean, you can think of it as not as attractive as zinc. So even though I think it's pretty, but whatever, no reaction. This is the only type of chemical equation you will write no reaction for if there is no reaction. All right, we have strontium, which is an element, nitrogen, which is an element. So this looks like a simple synthesis reaction, right? So strontium, nitrogen will be, make sure you write the metal first. This one's on the left side of the periodic table. This is a nonmetal. So literally it's like naming. Strontium nitride. Boom. Next. Iron 3 chloride. This looks like, since we have a compound, it's going to be a decomposition, okay? So we have just iron plus chlorine. Wow, so difficult, huh? That's it. You don't worry about charges, you don't worry about diatomic, monatomic when you're just writing the words. That's it. So that, I'm sorry, I'm not writing these. This is a single replacement. This is a synthesis, okay? This is a decomposition. And the difference between this decomposition and this one is that this one had that magical, one of the magical 3 exceptions, so you had to do something different. This one didn't, so we just separated it. It's very easy. nickel 3 cyanide plus aluminum permanganate. So this one has two compounds. Okay, so we're looking at two compounds. They're going to switch places. This is one where we just assume the reaction happens. So all we have to do is just bring the words down. I'm sorry, give me a second. So we're just going to bring the words down. So nickel, don't forget your Roman numerals. This is a double replacement. So this will be nickel, I'm going to spell it right this time, 3. And then don't forget your Roman numeral, and don't forget to switch the nonmetal. Permanganate. Okay, so that's it. You don't have to worry about charges. You don't have to worry about anything when you're just writing the words only. Plus, okay, plus, we still have the other one. So nickel went with permanganate. Aluminum's going to be with cyanide. So we're going to write aluminum cyanide. That's it. You just switch the metals with the nonmetals. That's it. All right, acetic acid plus potassium hydroxide. So again, this is a double replacement, but this is that neutralization. You see how it has an acid and a base? You know it's a base because it has an OH, okay? Potassium is a K. Acetic acid always starts with an H and then acetate. Oh, I don't want to give away the answer yet. Hold on. This is neutralization reaction, okay? So neutralization, double replacement. Neutralization is a special kind of double replacement reaction where we have an acid and a base reacting to make a salt and a water, okay? That's it. Anyways, we have acetic acid. It's always best to write hydrogen, and then if it ended in IC, make sure you know your naming. If it ended in IC, that means it ended in 8. So 8, so it'll be C2H3O2, but that doesn't matter. We just need to know its name. So hydrogen and acetate. Sorry, Jordan's having coughing fit. Hydrogen and acetate. I like to write them down separately so we know how to switch it. So the hydrogen is going to go with this hydroxide. So that's going to make, you see how there's 2 hydrogens and 1 oxygen? It's literally just water. Okay? Now we just need to know what the salt is. Okay? So the salt's going to be, acetate is the nonmetal. Okay? Potassium is the metal. So that's it. Potassium acetate. Boom. Potassium acetate, which is the salt, and water. So that's a neutralization double replacement. All right, we have barium and hydrofluoric acid. So this looks like Mr. Steal Your Girl, single replacement. Okay, we have a metal and we have an acid, but it has a hydrogen in it, which acts as a metal. It's not a metal, but it's going to act like a metal. So we have barium, and again, rewrite that acid with hydrogen. We have hydro and ic. That means it ended in ide. So we have a fluoride. Always misspell that. And what else? Nickel. All right, so we have barium, we have hydrogen, we have fluoride. Let's see if barium is higher than hydrogen on our activity series list. If it is, they're going to switch places. Hydrogen here, barium all the way up here. Okay, wow. Okay, so yes, barium's going to switch places with hydrogen. So with the single replacement, barium will switch places with hydrogen. So we have barium, every time, fluoride plus hydrogen. That's that really fun gas we lit on fire. Look at how I spelled hydrogen. There you go. All right, that's it. So that's how you do single replacement. Just check to see if this guy is higher than this guy. If he is, they're going to switch places. That's it. And then make sure you change the ending because it was hydrofluoric acid. Now it's barium fluoride. Anyways, zinc hydroxide. So zinc hydroxide, this looks like a double replacement. We have one double replacement. We have one compound here, and it's going to break into 2. So we have, actually, this is a special case. I was like, how is that going to break down? That's weird. This is a double replacement. Okay. Remember, there's that chlorate, carbonate, and hydroxide exceptions, okay? So hydroxide is an exception, and if you'll look in your notes, it breaks down to a certain way. Hydroxide will always break down into a metal oxide plus water, okay? So that's how it always breaks down, no matter what this is. This could be sodium hydroxide, it could be, nope, it couldn't be magnesium chloride, magnesium hydroxide, barium hydroxide. Whatever this metal is, it's just gonna go here with oxide and water. This always stays the product, okay? Just like this always stayed in the product, this always stays in the product, okay? When you have hydroxide. Okay, moving on. Okay, water and lithium. So water looks like an element because it's one word, but it's actually, remember, it's H2O, it's a compound. So we have a compound and we have a metal or an element. So what I would do, this looks like a single replacement because we have a compound and an element. So remember water, I would rewrite it as hydrogen hydroxide. Okay, and then we just look on the activity series sheet to see if lithium is higher than hydroxide. I remember lithium being the highest, but let's take a look and see. Lithium is all the way up here. Hydrogen is all the way down here. So lithium is definitely going to take the place of hydrogen. So they're going to switch. So we will have lithium hydroxide plus we have lithium hydroxide, okay? So all we have left is hydrogen, okay? Easy. Calcium bromide and chlorine. Again, this looks like a metal, non-metal compound added with a metal. Oh, nope, that's not a metal. Chlorine is... Sorry guys, again, I have not done this yet, so everything's a surprise to me. Chlorine is a non-metal, it's on the right side. We have calcium here, metal, bromide here, non-metal. So we have, it looks like a single replacement, but what's weird about this single replacement, sorry, this is also a single replacement. What's weird about this single replacement is that there's only one metal. So this is that weird kind of single replacement where we're looking at these non-metals. So no matter what, we have this calcium, right? All we're doing is going to see, okay, if chlorine's higher on the list than bromide, then they're going to switch places. If it's lower, then they stay the same. So let's look. So bromide needs to be higher in order for there to be no reaction. So bromide is lower than chlorine. So bromide is lower than chlorine, so it will switch places. I got lucky that it wasn't a no reaction. So calcium chloride plus bromine. Boom. Okay, done.